All right. So the first thing is Kubernetes is a framework released by Google, and it comes from the Greek word Kubernetes or Kubernetes, which is Greek for navigator or helpsman. Basically, it will help you navigate the Docker containers, I would guess. So yes, it's a container orchestrator. What this means is that we have Linux containers that need to be that if you work with Docker, you realize that the advised way to use Docker is to put one process per container, and basically it's an ideal framework for microservice architecture. And once you start working with microservices, you need to take into consideration that all of these services, your application becomes a lot of different services, and it becomes hard to manage and to do service discovery and to do reliable health checking and to make sure that the application stays up. And Kubernetes is designed specifically to address this problem. So to orchestrate your containers across a cluster of nodes. Which does not mean that if you have a monolithic application that you can't use it. I still believe, as we have seen a lot of reports recently, that microservices is this big hype that everybody wants to do it, but for a lot of startups it may actually not be the right architecture to start with. Microservices is something that you need to grow into, that you may start with a monolithic application, and as that you need to develop in a modular way, and as you then have your MVP or minimal viable product, once you start getting traction and you start to getting a lot of traffic, you actually may split off the modules, and in that case, when you choose the microserver architecture, you have the option to choose the best tool for the job. So if you need to write a socket server, you may prefer to choose Node.js. If you need to run Python, Django applications or computer vision, maybe there's a lot of modules there for you that you can reuse. So you can create a stack that supports many different languages. So I still believe that for a startup, it's also valid to look into using Kubernetes. Maybe not directly on a bare metal environment, but more into a managed cloud service such as Amazon ECS or Google Container Management. I think it's Google Container Cluster. Okay, so what Kubernetes gives us is the ability to run our own. So it's completely open source. It runs and manages the containers on either Docker or on Rocket. It supports, you can deploy it on DigitalOcean, you can deploy it on your VMware, you can deploy it on bare metal. And a lot of the concepts that are applied in Kubernetes are valid inside the Google cluster or the Google Cloud services as well. It's, as I said, it's 100% open source. It's a way of Google to introduce their 10 or decades of running containers in production. As they say themselves, they've been using containers for ages, and they want to jump on the container revolution to provide everybody with a way to work with it, and then realize that their services are actually the best ones, because then you don't need to worry about the management and the administration, but you can use their managed services. But you can play around with Kubernetes on your own cluster, so that's great. It's a very good idea. So as I said, decades of experience for running containers at Google. So it's container packaged, dynamically scheduled, and microservice oriented. They even provide Kubernetes as containers itself. So all the services of Kubernetes can be deployed as containers on other machines as well, which is not what I've done for my cluster. So let's look at the services that make up Kubernetes. Basically, Kubernetes is made out of an API server, which is controlling all of the through which all of the Kubernetes control needs to go. All the commands are directed at the API server, and the API server is communicating with etcd. etcd is a clustered key value store, which means that it has a high reliability to to run across multiple nodes, and in case of node failure, as long as you have consensus amongst the remaining nodes, you need to have at least 3 nodes. In case of one node failure, you remain 2 that can keep consensus. Your information will be stored. So it's different from Redis in a way that it's clustered key value store. So it's able to store all of the configuration in etcd. And if etcd goes down, your Kubernetes cluster is fried. So etcd is a very important part of the Kubernetes architecture, and usually you would need to run an etcd cluster separate from the Kubernetes cluster. In my demo environment, I have not done that because it's just a demo environment. Next, after the API server, there is something called the controller manager. His responsibility is to do a control loop to identify any actions that need to be taken, and then to schedule out to make sure that the scheduler is then called out to schedule the containers that need to be, or workloads that need to be run in the cluster. We'll see more about those 2 components, but those are the 3 main components that make up a Kubernetes cluster. The API server, which is a binary, a service that needs to run on the master. We have a scheduler which runs on the master, or which runs in the cluster, and where there's a single instance of, and a controller manager. The scheduler right now is it's a built-in scheduler from Kubernetes, but you can replace it by whatever scheduler you want. It's completely composable. You can take whatever piece you like from Kubernetes and run it by itself. You could replace the scheduler by Mesos, for example. If there is a question of comparing Kubernetes versus Mesos, I don't know how many people are familiar with Mesos is more focused towards scheduling, while Kubernetes also offers health check and other services, service discovery that Mesos does not provide. Finally, we have 2 more binaries running on the nodes. These gray squares on the right are representing our nodes for the cluster, and in there we have a kubelet and a service proxy. I probably should close my Skype. I'll put it to this. All right. So next, every node, as I said, has 3 components that make up the node. There is a kubelet, which is in control of the full node. Its responsibility is to report the health of the node and to report all of the containers that are running on top of the node. And then there's a proxy service, which is responsible for maintaining communication across the cluster, some kind of load balancer for the inter-node communication. Yeah, I wouldn't expect. When we talk about services, it will become more clear what the proxy does. And finally, there's the container run engine, or the Docker engine. In this case, it could be Rocket, which is an alternate container runtime. But for now, the most common use case will be to deploy Kubernetes with Docker. All right. So the first concept that is very new to Kubernetes is the concept of pods. Pods are combination. Just a second. Okay. Pods are the atomic scheduling unit within Kubernetes. Pods are can be multi-container or can be single container. Why would you want to have multi-container pods? Multi-container pods is for scenarios where you need to land multiple Docker containers on the same host. Pods provide a shared namespace, a shared memory, and shared volumes for containers that are within the same pod. Every pod gets an individual IP. So examples are, you could usually when you run containers, for example, we have an Nginx web server, we may need to have a log rotate service that runs next to the Nginx web server and automatically rotates the logs out. Or you could have a content management service that needs to run alongside another container. Just a second. Sorry. Okay. All right. So I was saying that the pods have, the examples that I was giving for pods were, for example, if we need to run a content management service alongside a web service. So the content manager may be responsible for pulling the data from a third party for another service and make it available locally to the web content service like an Nginx server. And so in those cases, we need to run those containers on the same host. They need to have shared volumes, or they may want to communicate with each other. Then the question comes, why wouldn't you just make one container with multiple services inside? The reason why Kubernetes does not advise to do that is because you want to be able to monitor the health of services separately across containers. Like a container should be one service and you can monitor the health. And the other reason why you would separate containers, multiple services into multiple containers, would be because you want to make reusable services. So for example, the example earlier of the log parser or the log rotate service, that actually may be something that you reuse with a lot of different services. If you bundle everything inside a container, then you have a difficulty of updating that log rotate. If you want to use a new one, you need to update it in every single container that is using it. Instead, you have just a separate service or a separate image that is running inside its own container, and you can just replace that part. So modularity is important there. That's one of the reasons why. Another important concept of pods is with Docker, changing a running container without committing the changes to an image is possible, but people can do what they want. Obviously, the concept of a running container is that it's immutable. If you change the container contents, if it's not persisted to a volume-mounted partition or file system, then the changes you made in the running container, if you restart the container, are all gone. So with Docker, people were still able to make changes, then commit those changes to an image. But with Kubernetes, the containers or the pods really become immutable. If you make a change, you need to have a new image. You need to make a new pod version. So it's not really if you come from a certain ideology within Docker, you may be familiar with this concept, but if you're not following that ideology, coming to Kubernetes may be require a little bit of an adjustment. So that's my quick overview of pods. It may become more clear once we start going through the demo script. The next concept that Kubernetes introduces is the concept of labels. So Kubernetes gives the ability to, when you define a pod, to define or to attach labels to pods. Labels are basically key value pairs. So there can be a key called the type of service, like the role, which may be front end, or the stage, which may be production. So for example, we have here a couple of pods. Those are pods. And the first one has a label called role front end and the label production. I'm not sure if this is, yes, it's clear. And we have a couple of other pods. Each of them have different labels. So by itself, labels have been introduced in Docker by itself. Docker has adapted this concept as well, and in Docker 1.8 or 1.7, labels were also available, or are also available already. But what this allows to do is, for example, we can now create query selectors to query all of the pods running in our cluster. And for example, we can ask all the pods that have a key of stage with the value of production. And when we run this, it will be able to run all of the production pods. It will be able to select all of the production pods. then if we concatenate more conditions to this selector, for example, the role has to be backend, suddenly the front-end production pod is no longer included. So giving labels to pods allows us to query the cluster for running pods. So it's, if you can understand, this is already a very big step towards service discovery. We're able to discover the running services within the cluster. So the next part is a little bit confusing. It's I look at the reconciliation concept, which is implemented inside Kubernetes. The reconciliation is a concept, or reconciliation is a concept from robotics, where you have a control loop, you have a declared state of what is desired state of the environment, and then you have the actual state. So if we are looking at our example, here we may say that our desired state is to have a pod running foo and a pod running, or a pod called bar, or with a label bar. And the actual state we report when we do an actual query on the actual running, it may show us that there's only a pod foo and there's no pod bar. So in this case, the control loop may identify that the required action is to create another pod with the label bar. What this gives us is the ability to just to repeat the same process in case that a container dies. For example, the actual state may identify that a certain container died, and when it does a health check, it may decide that it just needs to create another bar container. So instead of having a very big state machine of all the possible nasty scenarios we could get into, and then how we need to adjust or which action we need to run, the state machine becomes a lot more simplified, because it's just a reconciliation loop that just always checks what is actually running, what's the actual state, and then very quickly make the right decision. And all the code paths, for example, health check or create, they both go through the same code. They both have identified the same scenario where the desired state is running foo and bar, and the actual state is only running foo. So both the health check and the create are running the same code. So this reconciliation is a very strong concept to use within health checking, or to use within orchestration frameworks. Then the next part is an example. What if we want to delete a container? So for example, we have a desired state of only running container of foo. They're actual running both foo and bar. So in this case, it knows it needs to delete the bar, the pods labeled with bar. So this reconciliation process concept is applied to the Kubernetes replication controller. So a replication controller is responsible to make sure that to apply this reconciliation loop. So what it takes is, it takes a definition of the desired state, it takes a selector, and it takes a scaling number, which is to identify how many we want to have running of this desired pod definition or template. It's a pod template. And what happens is, it will do a reconciliation loop, it will run the selector, and it will confirm that the actual state is running the exact same amount of what we want to have running. So that's the job of the replication controller. So every pod is managed through a replication controller. You could create your own pods within the cluster, but that's not really how they would prefer to do it. And I actually don't know how that would be done, but as soon as you even do a kubelet run, it will actually create a replication controller for you that will then control the pods that you just decided to run. So the replication controller is a very fundamental concept of Kubernetes. Then once we've got all of those reconciliation controllers, making sure that the pods are running wherever they are running, because the scheduler decides where it could be running on any node, then we lose the ability to discover where they are running. So that's where we have the query selector, but we also need a way of exposing the query selectors to the external clients, because right now the pods, they are running on random machines on their own, with their own IP, so which is in like a virtual or an overlay IP. So the external clients cannot connect to any pods within the Kubernetes cluster unless a service has been defined. So the service is what actually exposes the pods to the outside world. So usually a service comes with a selector query, which defines what is this service going to address or forward to. I want to say load balance, but I'm avoiding the term right now. And you could define ports. It could be ports opened on the nodes, or it could be an IP. Okay, so when you define a service, what happens is there is a virtual IP created for that service inside the cluster. This virtual IP is virtual because it doesn't really exist. It's only added into the nodes IP tables. So Kubernetes by default uses IP tables to route TCP and UDP packets across all of the services that are running inside the cluster, or let's say all of the to route the packets to the actual service proxies. So when you create a service through the API informs all of the nodes, all of the kubelets, to add an IP table rule into the node that now the service is defined, and whatever traffic comes into port 80, for example, on the nodes needs to be load balanced across certain pods that are running with certain labels. So the service provides a load balancer across all of the pods running, and this is a built-in load balancer, and we will have some time to look into questions about that later. I'm gonna check chat if there's something. Okay. All right. Yeah. Don't forget if you have questions, because I know there's a questions about these services. So I guess we're gonna talk about the questions maybe after we do the demo. Maybe it will be a little bit more clear. I will take more time to pause at that time as well. We're almost done with the theory, and then we'll start with the demo. All right. So yeah, that's what I said. We're done with the theory. So what I did actually to make this demo is I looked at a lot of his videos from Kelsey Hightower, and he has all of his demo scripts online. So it's really great if you search for Kelsey Hightower on GitHub, on Twitter, on YouTube. He has a lot of information out there, and he also released a book called Kubernetes Up and Running, and I haven't bought it yet, but I'm seriously considering. It's a really, really great material that he puts out there. All right, so let's do some demo. Okay, so I've created on DigitalOcean. If I find my digital, oh, there it is. On DigitalOcean, I have created a master Kubernetes node and 3 clients. I've SSH'd into the master. I actually need to do one more thing. I need to git pull Let me go to the GitHub repository. There is the setup script. Yes, I need to git clone. This is the old location of the repository. The new location is docker-saigon / docker-saigon. I'm not sure if that's actually visible on this tree. Alright. So I'm gonna git clone that repository here. Okay. Wow, very fast. Okay, demo. Alright, so the first thing I'm gonna do is I'm gonna list all of the namespaces that are available in my Kubernetes cluster. So right now there's a default namespace, and actually there's one more thing I want to do. I want to create the Kube-UI service. The Kube-UI service, okay. Okay, I just created the Kube-UI service and I'm going to open it. Sorry, I should have done this earlier, but unfortunately. Kube system. Okay, so right now I have the Kube-UI service running, which is by itself a pod running in Kubernetes. And it was not ready, but now it is running. And I've created a service isn't it? Yes, and it's running the Kubernetes UI if on port 8080 if I hit my master. My internet, my browser is extremely slow. Okay, so I just want to show you that most of the demo I'm going to do is going to be in the console, but they actually have a completely open source and composable user interface that people can build their own components, and some people have built cluster visualizations and so on, and I can give you some references to that. But for now the user interface looks very rudimentary. It's not very fancy, if it loads at all. I'm running way too many tabs, that's why. Oh, I need to kill this one. I'm sure it's running, it's just my computer is freaking out.
Sorry to interrupt, Vincent, because we have a question regarding to the
Yes.
the Cube the namespace from when you list the namespace. There is only default, but when you create the Kube-UI, you specify Kube system. If that's possible.
Yes, it will. It should create a new one. Let me see if that now is a new namespace. Yes, it created a new namespace automatically. Yeah. Yeah. Good question. Oh, come on. I'm running out of memory, that's why. I've killed everything. Oh, my internet is just extremely bad. Okay, let's forget about the UI, I'll show it later. Okay, let's continue with the demo then. I know that my cluster is running and the UI is listening. Yeah, great. Yes, that's the service. See, it's listening on the port 8080. Forwarding. Okay, it's... why nobody told me I'm trying to go to domain.com? And I'm gonna do the same error over and over again because last time I did. Yeah, wrong domain. Yeah. God damn it. And I said I'm going to do this same error over and over again. it's still not loading up. So it's gonna go to the IP. Something wrong with my DNS or and now I don't have an audience that is constantly pointing me out when I'm doing wrong, unless I go to the YouTube. God damn it. Okay, forget the UI. It's gonna come up. I know it's running. That's great. Let's go. Right now, my configuration. So what you need to do is, if you download the kubectl to your laptop, then you can control your cluster if you set up a configuration. So on my situation, I'm actually SSHing into the master. So I already have kubectl there, and it's already configured to connect to my cluster automatically. I mean, it's connecting to localhost by default, I would say. So right now it doesn't have any configuration. So obviously, if I were an administrator and I would need to create a configuration for my client machines to connect, and then drop that config to the client machine. So the first thing I'm going to do, I'm going to switch to, I'm going to create the demo namespace. And again, I'm not in the right. So when you change things around. Okay, namespace demo has been created. And I'm going to set my default one to demo. Actually, last time I that didn't work. And I'm going to look at the config. So now my context is set to demo namespace. What a namespace does is it's a way to isolate containers running or pods running within the cluster. It's not really something you would use to isolate different tenants, because then there may be a way that they can affect other tenants within the cluster. Even if you would use namespaces to isolate stages like production from test staging, that wouldn't be a good idea, because if one process goes crazy in staging or testing environment and kills a node, it may affect your production environment slightly. So it's not a good idea to use one Kubernetes cluster for multiple staging environment, or for multiple, like, at least don't share your production on the same Kubernetes cluster. Of course, if you're an MVP and you just if you're a startup and you just want to get something up and running on Kubernetes, I would say, yeah, fine. So the first thing, yeah, that's how we check the status of the cluster. That I did that earlier. So the first thing I'm going to do is I'm gonna run the inspector image, which is an image created by Kelsey Hightower for his book Kubernetes Up and Running, and as you can see, it's hosted on the Google Container Registry.io, so that's where the image is being pulled, and I'm pulling for the tag 1.0, and it's going to run this, and it's going to attach the labels app equal to inspector and track equal to stable. So there's two labels with their values there. I did not specify how many replicas, so automatically it creates a reconciliation controller, sorry, a replication controller, and I'm gonna make that mistake again. I'm looking. Oh, my UI came up. Okay. Yeah. Exactly. Yeah, somebody saw the UI came up. I'm reading the chat. Okay, I'm wasting time. So I'm making the same mistake over and over again. It's replication controller. So, like I said earlier, everything you do, every pod that you run, like kubectl run or kubecontrol run, it actually creates a replication controller that will control the instances running or the replicas running. And if you don't specify how many replicas you want to run, it will automatically assume one. So right now we have a pod called inspector with a controller inspector. Okay, so next we're gonna have a look at all of the reconciliations controller that are in the environment, and yes, we have obviously we have the inspector running inside our demo namespace, and we have the Kube-UI running in our Kube system namespace. As we have the UI, might as well go and have a look what we have in here. We can have a look at the actual replication controllers, and you will see that the Kube system namespace is hidden here. We can just see only the other namespace here, the inspector running. Okay, so the next step is that's the replication controller, and if we look at if we describe a pod, so we can write kubectl describe pods. No, I'm not sure if it's pods or pod. It's pods. Okay, and you can shorten it just typing PO. Replication controllers, you can shorten it with RC, and services with SVC. So I'm usually using the short name because I like that. Okay, so here we see the inspector pod that it's running. This is the name. It has a unique name, and actually it's running in default namespace. Again, like the last demo, it's not running in the demo namespace. I probably should look into that, why that's happening. And this is the node it's running on. This is the node name and the node IP. Because I don't have a proper DNS running inside my cluster, the name is forced to the IP. So whenever Kubernetes tries to resolve the name, it actually doesn't need to do any resolve because it's the IP. So it's a hack. If you set up a Kubernetes cluster, you should have a DNS system to make sure that the host names or the node names can be resolved. Next is the labels that are attached to this pod, and the status, and also the IP that this pod received. This pod has received a separate IP within the overlay network. Because every pod needs to have its own IP, and because a service provider or cloud provider like DigitalOcean does not give you like 20 IPs per VPS, right? You just get one. So that's why you need to kind of create an overlay network. What I did here, I'm using Flannel, which is a product also from CoreOS. I'm running CoreOS. Okay, I'm running CoreOS version here, alpha. And I like CoreOS because it comes with Docker and everything installed, so it's very easy to provision VPS for Kubernetes with that. It also has Flannel in it as well. So once you have Flannel, Flannel allows you to create an overlay network, a software-defined network, and inside that network I have assigned like a pool of, I don't remember, it's like a whole 255 IPs to one node. That means that there can be 255 pods running inside one node. So every node has a 10.244.13.0/12 DNS namespace. Subnet, not namespace, subnet. Okay. Okay, so that's enough. We can see also a little short logging of what happened with the pod when it started, and I'm talking way too much. Next, we can have a look at events that get risen inside the cluster. So I'm gonna run a watch below, and I'm gonna scale the pods. So I'm gonna tell, yeah, I'm copy pasting all the time. Earlier somebody make a comment. So I'm increasing the number of inspectors running to 10. So right now the inspector service is being scaled to run 10 services. As you see, 10 pods are being created, and initially there is the message that they have been created, and then secondly there's an event showing when every pod starts to run. One by one they come online. So what happens here is whatever node it got scheduled on pulls the image of the container, the image for the container, and then spins up a container running that image. So you can see it takes a while for some of them to come up because the actual nodes have to pull the images one by one. So I can get pods to see the status. As you see, 5 of them already came up, 6 came up, and the rest of them are still starting. I get by now. Yeah, there's still a couple of them starting. Right, so we get events for everything that happens in the cluster, so we can monitor those events and we can start like billing processes is the classic example. Okay, the next step is we're gonna create a service, because as I said earlier, the pods are now running all across the cluster, and we have no way of accessing this from externally. So to be able to access the pods, we need to create a service, and this is a service definition where we can see the name of the service, and we can see the labels that it selects for. So it's looking for pods that have a label of key app with the value inspector. So only those pods will be selected, which is the only pods that are running right now. And the service is defined to open a port on every node. So of course you have a limited amount of ports. I guess this is not the recommended way to expose services, to open a node port, because then if you have multiple people using the same cluster, you may have conflicts between the people, the ports that they're using. So ideally you would use another way, but as this is a demo, let's just use that way. This is just to show what are the actual pods that have the label app inspector, and those are all the pods that we created earlier. So if I create this service now, okay, so what happens is it gives us a warning that the pods, that the service has been created, and that, as I said earlier, a service is kind of an IP table rule, a virtual IP, and a load balancer. So right now, the kubelet, the kubelet, which is running on every node, has added an IP table rule. So whenever a packet comes in on port 31000, that packet is then forwarded to the service, and then the service goes out to the cluster to find all of the inspectors that are, or all of the pods that are running the inspector app, and then load balances across those. So right now I have opened this port 31000. So if I go to any of the nodes and I go to 31000, I should hit the inspector, and I don't see anything. And this is
Thank you very much.
great. My demo is going very well.
The green one, sorry, the orange.
Yes.
Node 0, port 31000. Oh, yeah, here it works. I'm running out of memory, that's why. Okay, so I'm hitting node 0 on port 31000, and I'm getting the inspector web application. Okay, this is a very cool little image that you can play with, because it shows you, it gives you a full inspection into what is available or made available to the pods within the Kubernetes cluster. Gives you a little bit of information about the network. So right now, if I refresh, I should be getting different IPs, but we had the same problem, so I'm not going to waste too much time on that. Yeah, it's not showing, but if I do a loop curl, then you will see it change. One of the things is that it exposes the services. So right now the Kubernetes service is exposed within this pod. If I run a Postgres service or a database, then if I expose that, or if I define that service in my Kubernetes cluster, Kubernetes will publish an environment variable in every pod that contains the IP or the connection information for that service. So for the pods within the same namespace of that service. So if you don't want pods to see services across different applications, you will need to create separate namespace to isolate them. So all of them are here, those Kubernetes variables, environment variables. Next, I think I'm going to show just the mounts, and then I'm going to look at chat if there are any questions. So here we have the var run secrets Kubernetes. Kubernetes mounts a path where it puts the Kubernetes service account token, and using this token you should be able to communicate with the Kubernetes API. And just a second.
Okay, it's fine.
Yeah. Yeah, unfortunately I had to move out of the office. So. Alright. Just a second.
Sorry, thank you. No, that's all right. Thank you. I've just got one more page coming through, and then I'll finish.
Alright, no problem. Alright, sorry for that. So yes, Kubernetes does a couple of things that are interesting for your containers to run. If you build your containers to run on Kubernetes, you can take advantage of those things. The next thing that I want to do is I want to show you that I have created a load balancer. Okay, we can kill that one. I think I'm not going to be able to connect, yeah. That's fine. Okay, so I have an Nginx proxy running, and on that it's basically running outside of my Kubernetes cluster, and in that one I'm load balancing across my 3 Kubernetes nodes to port 31000. So whenever you hit this IP, and I'm not going to copy from the demo script, so I'm not going to put the wrong domain. If I run this IP, yeah, I should restart. And I'm going to Alright, so I changed my my load balancer, but I had not restarted my Nginx, that's why it didn't come up. So right now it's hitting this. So now I have a load balancer outside of my Kubernetes cluster, which is hitting different nodes. And whenever I refresh, I should. Yes, now I can clearly see I'm getting different IPs. Different pods. Okay. All right. This is interesting. Okay, I can scale it back. Okay, what I can do is I will scale down the number of inspectors running. But before I do that, let me check if the chat, if there's any question right now. We can make a remix of the printer. Yeah, unfortunately, I didn't have ability to do this from my office. Auto scale. Okay, not much else going on. Just that people would love to make a remix with the printer. I would fully support that. Let's do. What I want to do is I want to run this loop . Okay. Alright. Oh, this is, sorry, this is not what I wanted. I had another one where I was getting the IP. Forget about that. We already saw the IP change, so let's just do this next thing where we're gonna monitor, and what we're gonna do is we're gonna we're gonna run a separate image. We're gonna deploy. Yeah, we're gonna do the Canary pattern. The Canary pattern is a concept where you just deploy one instance of the next version of your application, and then you put it inside the load balancer, and randomly, or the load balancer will assign traffic to it, and then you can monitor how the application is doing if you have the expected outcomes. And so we're going to deploy the Canary, and because we have a label called app inspector, automatically you will see that this starts to be picked up by the load balancer. So that's what we're doing here, and my focus should be on the top screen. Okay, so right now, not Docker. Right now we have 2 canaries. We did scale, we did run replicas too, so it's running 2 canaries. And below we should start seeing, actually they're still pulling the image, the node is still pulling the image. So let's do a refresh of that. And they are running now. And we see already that version 2 is being picked up here. So version 2 is being picked up by the load balancer. So the next step is we monitor if the Canary is going fine. However, we may want our testers to be able to consistently hit the Canary, right? I mean, it's no point for them to just randomly test. So in this case, we may want to expose the actual, sorry. Alright, yeah, I haven't actually exposed the Canary. I need to make, see, I have on my load balancer, on my Nginx load balancer, I have created another upstream definition for Canary inspector, which is hitting the ports on 31001. So I'm gonna expose this port in a service again to make sure that this is only going to select Canary instances. So in my inspector Canary, you will see we are opening 31001, and in my app, in my selector, it's including the track, so it's only the Canary. If we compare this to our earlier service, only selecting for app label inspector. Okay, so the app label had to have the value inspector, so it's hitting both. But the new one, the Canary one, it's actually hitting only the app where also track equal to Canary. So we're gonna create that service. And again, every command that you see me do here, it's available on the GitHub repo, so you can repeat the full demo script. So I might seem cheap copy pasting all the time, but it makes it cool, right? We're actually going over time already. I should have been going towards questions by now. So right now we have opened the port 31001, and now if I hit my Canary, obviously we are actually hitting the inspector version 2, and it will consistently hit version 2. So if we stop the loop here and we're just gonna hit the Canary instead, we are consistently getting version 2. So there's no version 1 in there. So if somebody wants to test the Canary, they can go to this DNS and they will be able to test this properly. All right. So next, self-healing. So what we're gonna do is we're gonna kill a pod. So we're gonna look at the events in the bottom window, and what we're gonna do is I hate it when my mouse jumps down. Get pods, right? So I'm gonna kill, let's say I'm gonna kill one Canary, so I'm gonna kill this one. Delete this pod. Let's say it dies for whatever reason, so kubectl delete pod. Bam. pick it up. Alright, so as I did that, instantly the replication controller noticed that something went, down, and a new Canary was created, and it just took a couple of seconds for this to be scheduled out to a node, and then that node to pull the image if it wasn't there already, and then actually start running it. So very fast, just instantly another instance has been started. So even interesting would be to run, I'm not sure. Oh, I think I'm going crazy. My computer's already. What I want to do is I want to open another window. Let me open. Oh, forget it. Okay, let me just run another. Instead of looking at the events, I'm going to loop over and curl the service. So what it's doing again, I'm repeatedly curling the service. I'm going to kill FBE7, and as I killed it, you never see the service dropping any packets. It just keeps going. The service is automatically selecting whatever pods are running and only directing the traffic there. So there is no lost connections there. All right. So that was the self-healing concept of Kubernetes. As we killed a pod, it automatically healed itself. So the next thing we're going to look at is so we did the Canary deploy pattern. We did show the self-healing. Then there's this short concept of how can we take one. How can we take one? Right now, we have our service selecting for app inspector track Canary. If I want to look at one pod, like if I look at my pods. Let's say that I notice something strange going on with this pod, and I want to take it out of the service of the load balancer, and I want to go in there and inspect and play with it, but without affecting the other the live environment. So I can remove the labels, for example, by and let me remove the app label. And when I do that, didn't it do that? That's not get pod. Should be delete label. Oh, sorry. This is listing the pods that have the label Canary. Okay. What I need to do is I need to delete the label. So I'm gonna. I always forget. Label pods. You just need to do. Let's say we pick up this one. Yes, makes sense, right? And we say remove the app label. It's admin, right? I'm removing the app label. So what happened is another pod spinned up 3 seconds ago. You see this one. That one is still running, but I know, for instance, this one is never gonna get hit by the load balancer. That one is now isolated from the load balancer because it no longer has the correct labels to be considered by the load balancer. And this allows me to do troubleshooting and I can see all of the gets that this pod was receiving, and I can from one centralized place I can do full troubleshooting. I can get the logs, and I can probably enter the container as well. So right now, yeah, if I describe the I want to describe that particular pod where I removed the label. So I will describe this pod. So using describe, I will get an overview of what are the labels that it has. So here we can see right now it only has one label called track is Canary. Okay, so we are able to isolate pods. The next thing is to perform a rolling update. But before I do a rolling update, let's have a look if there are particular questions. Okay, when undo, you can ask me some questions. Anything I missed? And yes, I practiced a lot because I did this already 3 times. So, are there any questions? Okay, I'm just going to continue. I think we lost a lot of people when the printer started playing music. Next time I'll make sure I have a proper.
So we have a couple of questions.
Go ahead.
But actually, I think. So did you finish your demo?
No, I will do the rolling update later. But let me just listen if there is anything.
And we have a couple of questions from Quinn, I think, on Meetup site, and I will check it.
Yes, there's a question regarding the load balancer that was created when you create a service, right?
3 questions from Quinn on Meetup website. First one. Okay, so let's continue.
This is funny. No? Okay. I'm still waiting. Alright, that's okay. Alright, so final step is the rolling update. So what's the concept of the rolling update? First we're gonna pull the version. We're gonna be pulling the inspect. The web service is called inspect, not .domain, right? It's called inspect.ludino. I'm not gonna make the same mistake. Alright. Yeah, don't bloody issue this. Okay. See, I only made the mistake once so far. Oh shit. I have to type this out. Alright. Okay, we have 3. 7.5. Done. Hey. 0.5, not 0.3. Okay, so we're running the curl across the inspect ludino.com. We're getting different versions. I'm gonna delete the Canary. We're happy with the Canary. I need to delete it. Let's just delete kubectl, delete rc inspector-canary, inspector-canary. Okay, so now we should be only getting version 1, right? kubectl get pull. Right, we have Canary and we have that idiot that we just took out, so let's just delete that guy as well. GTL delete bot, this one. Alright, so right now we only have inspectors running. Let's scale down. Scale. Okay. We're gonna scale it down to, let's say 5, otherwise the rolling update is gonna take a while to replace all of the replicas. Alright, so we scaled it down to 5 pods. So automatically, poof, only 5 remain running. So now we're gonna do a rolling update. So what's Kubernetes going to do, it's going to, when we do a rolling update, Kubernetes is going to create a reconciliation controller for the new version. So we have, right now, we have one reconciliation controller for version 1.0. So Kubernetes is going to create a new, and it has a scaling of 5. Kubernetes is going to create another reconciliation controller for version 2, and then it's going to scale down the version 1 and scale up the version 2. And so that's how it's going to do a rolling update without taking down the application. So right now, if I go, actually we're not seeing the rolling update. Okay, so right now it's the first one at the beginning. It created the inspector replication controller with this long hash, and it first started scaling down from 5 to 4 on the version 1, and it went to version 1 on version 2. Then it started, after that went fine, and you see version 2 is coming more and more. It went to 3 replicas and 2 replicas on version 2. Then it went to 2 replicas on version 1 and 2 replicas on version 1 and 3 on version 2. And once that's done, it goes to 1 replica on version 1 and 4 on version 2. kubectl get rc. Okay, right now you can see we have two replication controllers. One is for version 1 and one is for version 2. Once the loop has finished, he updates the inspector version 1 to 0 and version 2 to 5. Once he's finished, he renames the inspector to the new inspector. So now we just have one left, and this time it's now running version 2. So initially we had an inspector which was running image version 1, and we had a temporary inspector for running version 2. Once the rolling update has finished, it renames the inspector that was version 1, removes that one, and renames the temporary one to version 2. So now we're final in version 2, and we are getting just version 2 here, and the website was updated smoothly. Yeah. I can go to the meetup. Yeah, my computer is totally fried. I want to go to the dashboard. Okay, the Kube-UI dashboard basically shows me my node, and it shows me the memory usage on each. Right now you see that the file systems bars are constantly changing, and that's because the CoreOS operating system is randomly sending the file systems, right? You see it has 3 file systems, and it just switches the positions of them all the time, which is why the bars are constantly changing. It looks cool, but it's stupid. And I've opened the ticket, and there's probably a way to make sure that the file systems are reported consistently, so it doesn't always change. But this Kube-UI is, you know, it doesn't. If you install a Kubernetes cluster, it doesn't come automatically. You have to, like you saw me do, you have to pull the Kube-UI images from the Google Container Registry. I need to run them. Okay. So because my stupid browser is freaking out. I have not answered the question on Meetup. There were basically 3 questions, if I remember them correctly. I'm trying to go there, but the question was, how does the service work? How does the load balancer work? So it's really complicated concept. Like the one that I just created, I understood there are 2 different types. You can set up a cluster IP, and then the load balancer will, like I said, the service definition creates an IP table route on the nodes, and whatever you know, whatever node is hit with that IP or that port will then be through that IP table forwarded to the service proxy, which is then doing the load balancing across the pods. Even that explanation to me is still not very clear what exactly it does. So the next thing about the service, the question was, can we change this load balancer for our own load balancer? I personally have not changed it. I know that, for example, Suker from the Slack channel, he has been playing with it and run his own. Just a second. Hello? Yeah, can you come to the business center? I'll come down in 10 minutes, okay? You know when it's finished, okay? I'll come down in 10 minutes, alright? Bye. Okay, sorry. So the question was regarding the load balancer. I don't know how to change it, but as far as I understand, Kubernetes is fully composable, and you should be able to switch in your own load balancer. Just a second. Alright, then the second question was about the how to use Kubernetes with a private registry, and I have not tried to do that myself, but I've researched it shortly, and oh, you've got to be kidding me. Action is really slow. Go to the Kubernetes documents, under the user guide. There is under the user guide, you have a detailed walkthrough under the application administration, working with containers. And when you look at that, Kubernetes user guide, managing applications working with production containers. So in production, they say you could have a private registry, authenticating with the private registry, and they give you an example. Usually when you do a Docker login, the login information is stored in a config file, and then you can use that to create the pull secret for pulling images from the private registry. And if you click on the image registry credential information, you will get more information about how to use a private registry. And if you go to the secrets topic under the concepts, so if under the overview, secrets, there is an explanation about secrets and how to manage the image pull secret, which is the secret used to pull images from a private registry. So there are definitely ways to do that. Okay. Right, so that was just how to pull private registry images. And then the third question was about, sorry, the third question, I'm trying to think, I can't open this website right now. Feel free to put it in the chat. I remember I didn't know to answer the third one. It was about SSL. If you deploy the Kubernetes cluster and you're running SSL, you didn't run SSL in your cluster and you're wondering how safe is it. And if somebody here, like when Antu has a comment on that, right. So right now, I think this is an interesting topic. Definitely the private registry, because I want to run my own private registry as well. But I think we can. Right, this is the repository on the docker-saigon GitHub. We're gonna make another one where we start, or maybe we can create issues or a wiki where we can try to troubleshoot. If we find some information is not clear, we could make some documentation. But anyone who just watched this demonstration can just go to the setup DigitalOcean scripts, where there are full scripts on how that actually connect to DigitalOcean and use a DigitalOcean control tool to provision the nodes and sets up the whole cluster for you. So that's very cool for anyone to just play with Kubernetes. If you go to the Kubernetes website, there's a lot of information how to set it up on ESX, how to set it up with other environments. So we could do that. Is there any other questions? Right, the naming conventions. If you look at the services in the overview and concept, you will see information about how these services are environment variables. So when a pod is run on a node, a kubelet adds the environment variables for each service, and there can be compatible to the Docker link way that variables are created. So when you link to containers, similarly Docker links also create environment variables inside the container, and they have a certain naming convention. Or you could use a separate way of doing that, so a separate naming convention, so you can control that. And that's how you would then discover the application, discover the services across within the cluster. So, and as I showed earlier, the inspector image is great to have a look at what's available. Yeah, I killed the Canary, that's why it doesn't work. So if I look at the environment variables, right, you see here the inspector service was created, and bam, you have the inspector in there. It's funny because I just deleted it. So I wonder when that will go away. It's an interesting question. Yeah, let's look at when that goes away. Right, yeah, we don't need console because the service, the concept of the service within the Kubernetes cluster is for doing service discovery. So they completely decouple the hardware, like it can be running anywhere, and they give you the ability to just use this orchestration framework. So it's not just scheduling, it's also service discovery. And they give you all of those tools within Kubernetes. It's completely composable. You don't want something, you want to take something out, you can do that. For etcd right now is just storing the configuration. So the API server uses etcd to store the configuration. The service discovery, you really do it using the the services that you create within the cluster. That creates a virtual IP and IP routing tables that I explained earlier. Okay, I'm afraid my time is up. I'm sitting in a, as you can see, business center, and I need to go. So thank you for watching. Yeah, I hope, and we can continue the discussion on our Slack. So if you go to the docker-saigon.herokuapp.com, that's where we actually have an automated invite bot set up. So you put in your email address, you will be invited to the Slack channel. And in the Slack channel, we have, yeah, joined already. Okay. So in the Slack channel, you can normally check out full history and search very quickly. All right. I need to go now, so thank you and bye.